Am I audible?
Yes, sir.
Great. So today we'll start panel data. Anything which you would like to ask regarding your assignment and all? Anything?
So for the forecasted value in Garch, which of the year value do you consider? As in, we find multiple values like for 10 years or something. So can we take any of the values, or in particular, do we need to take the last value?
Which values confusion are among what?
So as in, after we perform the Garch model, we
Uh-huh.
estimate, we forecast the values, the
Uh-huh.
variance. So which value to consider for of the forecast?
So when you give the command for forecast, only select the option that you would like to forecast for the period for which you do not have data, and rest you deselect. Then you will get fine, very appropriate forecast values that you can
Yes,
use.
sir. Yes, sir. So suppose I got four values in the forecast. So out of the four, which value
So
to?
So, suppose you are taking weekly data, then first week, second week, third week, fourth week, if you have forecast four values. So clearly, if you have
Okay, sir.
data, let's say for up to this week, then weekly forecast will be available. Frequency will remain same. The way you have data, you will get the frequency, I mean the forecast data.
Okay, sir. Okay.
So let's have some brief discussion on how do you differentiate between cross-sectional and time series data. Then I'll come to panel data. Yeah, please go ahead. Somebody. How do we differentiate between time series data?
So for the time series, for a particular company, we find across various time periods, as in day one, day two, day three, day four. And in the
Mhm.
cross section, it's day one, but for multiple companies.
Anyone else? Yeah, anyone else? Ayushi Tabarwal. How do we differentiate between cross-sectional and time series data? Is Ayushi there? Dikshit Kumar Jain. Is he there? What about Dikshit Kumar? Ayushi is saying that she has got mic issue. Yes, Abbas.
So basically, time series data is taken over a period of time for a fixed variable. We take the data for the long period of time. But for cross-sectional data, we fix the time and we take for the that time period, we take the data for across the sections, like for
Okay.
whatever field we take.
So cross-sectional, any other view that what are the limitations of cross-sectional data? If you have just cross-sectional data, I want other people to respond. Where are the people? Dikshit is absent. I mean, just logged in. Akshay Rawat. Akshay.
Yes, sir.
Ha, Akshay.
So
What
about
are the
cross section,
limitations? Yeah.
yeah, so the cross-sectional data refers to the data collected at the same point of time, like
Hmm.
without any regard of differences of time.
Okay.
That's, I guess, that's the limitation. And in time series data, the data is equally spaced between time intervals.
Okay. So what we are saying that cross-sectional is good, that we have got many variables and we are trying to find out association. But the bad thing is that we do not have that study over the period of time. On the other hand,
Yes.
when we look at time series data, then we have got variables over the time, but cross-sectional wise, we are not having very great situation. So what happened if we try to mix the two? If I just try to write down, y I, let's say I'm putting some suffixes now so that we have a clear-cut differentiation that what type of time data we are dealing with. So I can write down beta 0, beta 1, x1, I. I'm putting, I could have been easily removed, but I'm putting it beta 2, x2, I plus ui. So this is one example of cross-sectional. Even if we remove I, it will remain same. And if you look at the time series data, what happened? We write, I mean, instead of I, I'm putting t. Beta 0, beta 1, x1 t plus beta 2, x2 t plus ut. So this is the example of time series. If you look at these two, what is the difference practically? Yes, what is the difference? Yes, Ashna, Ashna is there. Yeah, Tanay, just hold. Ashna is there.
Yes, sir.
Ashna, what's your understanding that? What is the difference? Except I and T, what is the difference?
No idea, sir.
Practically, if I just look at the expression, then there is no difference. Here we are studying cross-sectional wise. We do not have any idea about time. We are not bothering. Rather, we are assuming that time period is one. When we are studying here, we are not bothering about cross-sectional. Rather, what we are saying that over the period of time, how y is going to have some relationship with these variables. But at a particular point of time, what is happening that we are not bothering here. So here at a particular point of time, no study. Over the period of time only we can study. Variables can be same. Variables can be same. Let's say I'm saying dividend. So dividend is something which I'm studying. It is a y, and let's say I'm saying that this is ROI of the company, and X2 maybe interest coverage ratio. So if we are studying cross-sectionally, then we are having at a particular point of time same relationship. This is y, this is x, this is x2. But we can have same study over the period of time. Then we'll have not the cross-sectional wise, but we'll have cross-sectional means, I mean, when we say cross-sectional, then we are having, if I say sample, I mean this I as I used here, so I will be having the values of 1 to n, where 1 to n is nothing but companies. Let's say I'm talking about companies. So companies, we have got n companies, that is the sample, n is the sample size, and we are studying. And if we do time series study, what is happening? Same thing, but here we have got time. So when we say time, it means company is going to be one. Please pay attention to this. One company. So as we said, one time period. Similarly, here we have to say one company, and for one particular company, when we say that, let's say there are T time periods, or this is the sample now. So I'll say that year 1 to year T, let's say T is equal to 10 year. So I'll say that I have got data of a particular company, same data of dividend, data of ROI, data of ICR, interest coverage ratio. But right now I'm not talking about different companies like I did in cross-sectional. Rather, when I'm talking about time series, then I'm just talking about a particular company, but over the period of time. So this becomes time series study. So same regression, same expression, only difference that here we are talking about cross-sectional, here we are talking about time series. So cross-sectional will have single time series will have single company. So if I use this language, slightly different approach, so I can say in cross-sectional, we have time fixed or fixed. I don't want to use today a term. I'll call it time is one. And when we talk about time series, then we are saying that cross-sectional data is one. I have used this term. Cross-sectional means a number of items in the data. So cross-sectional meaning is coming from here as number of companies. So when I say cross-sectional data is one, it means company is one. So I'm not calling it company. I'm just saying cross-section. This nomenclature you are following?
Yes, sir.
So what is happening when we are having these two separate way of doing the data analysis? First of all, let this this idea should go to you well. I mean, we are having cross-sectional, we are having time series, and this idea is clear. I believe that is. Still, if you have any doubt, please ask, because we are going to complicate this whole thing. This is what is the complication. In the nature of cross-section, in the nature of time series, we are going to have more complication. So it is better to have clarity right now so that when we make it complicated, it can easily be understood. So feel free in raising your question. Sanjay, I mean this Akshay Rao or somebody, is he there? Akshay Roy. Ayush Roy. Sorry. I'm sorry. Ayush Roy. Akshay Rao. Ayush is there? Where is Harshdeep Singh? Manisha Thakur? All these are sleeping students, just logged in and sleeping. Yes? Yes, Manisha. Yes? Manisha came and again went back just to show that she was there. Where are the other people? Swapnil. Is Swapnil around?
Yes, sir.
Yes, Swapnil. So, do you have any issue with cross-sectional time series? Are all clear?
Sir, if you can give an example of cross-sectional data, that would be great.
Cross-sectional, like you did your assignment. What was your assignment in regression analysis? Time series was there.
Yes, sir.
Like I want to study the same thing as I told you. This why this dividend is function of ROI and interest coverage ratio. So this is when I'm saying that study this, let's say for 2019 and for let's say BSE 30 companies. So it becomes cross-sectional. Huh? So here it is fixed. I don't want to use term fixed today. I'm talking about final data. So given, make it this way, given. And then same relationship, when I say dividend is equal to ROI, interest coverage ratio. But right now I'm saying that let's talk about one particular company, let's say for argument's sake, RIL. and study for last 15 years, maybe starting from 2005 to 2020. So same relationship, but right now this is time series study, and when we did this, it was cross-sectional. Yes. Where Swapnil has gone? Swapnil?
Yes, sir. Got it, sir.
But it's better now.
Yes.
Sneha, where is Sneha? Is she there? Sneha, we have got two Snehas. Rajiv, Satish. And where is Rajvardhan? Is he there? Rajvardhan, not have not spoken so far. Rajvardhan.
I'm here. I'm here, sir.
Great. Rajvardhan is one of the consistent students. So this was the some basic idea about cross-sectional and time series. Still, when I proceed, if you have doubt, you can again go back. So right now, what we are talking about is that here we have a limitation. When we say cross-sectional, then we have limitation that time aspect is lost. We are not some way or the other can talk about time. Similarly, when we are studying time series, we are not talking about cross-section. We are not talking about different companies. Rather, we are only talking about a particular company. So this limitation makes it less information worthy. Means when you study this, you are having a clear-cut, well-defined limitation that you are not studying this in terms of time. So you can't compare what has happened yesterday with today, and you will not be able to compare what will be happening tomorrow with today. So that is a big limitation. Similarly, you are only talking about a company. You will not be able to, in time series data, you will not be able to compare one company with another company, that too in same regression. You could have one regression for one company, another regression, another time series regression for another company. So somewhere or the other, if we try to mix the two, then you get to know something which we call parallel data. Panel data happens to be complicated. I'll try my level best to make things clearer, but discussion will only be meaningful only when you keep on asking. Because it's very easy to have a monologue from one side, but slightly good or slightly informative, more informative if you keep on asking. So that I know what you are understanding, what you are not understanding. So it is very easy to have a monologue on panel data, because panel data is shaped that way. So if I start with the expression, and we are going to be very particular about expressions. This is expression meant for cross section. This is the expression meant for time series. Now we want to mix the two, and we have to start with the equation only, expression only, so that we are having clarity. If I write it this way, y, if you have paid attention, I have written yi for cross section, yt for time series. Right now I'm mixing the two. I'm saying yit. So I stands for cross section. So let's say have some numbers. Let's say I'm talking about 3 companies, and when I say T, I'm talking about 5 years. 3 companies. So we are clear that when we are talking about this setup, so for example, we are having this. We can have 100 companies, we can have 1,000 companies, we can have 1,000 years, all are possible. But just for the sake of simplicity, we are taking some numbers so that we can talk. If I write further, as you have seen that beta 0, beta 1, beta 2 are not having any variation. We'll write first of all without variation, then we'll talk about variation, because variation matters. I'll write beta 0, beta 1, and look at here what I'm saying. 1, x1, still if I say that this is ROI as I have taken in the example, but I'm saying I stands for company and T stands for year. Then I have got beta 2, x2 it, and I'm using a term, I'm slightly changing it. I'm not putting it U. I could have done, but let me put it this way, VIT. So this whole expression can be used to describe, and this is, please pay attention, this you won't get so easily. You refer to many stuff, it would be very difficult for you to get complete clarity on panel data. It's very confusing to talk about panel data. So I have, when I'm writing this expression, I'm giving you a lot of input into this. I mean, a lot of work has already been done, and then I'm able to, present expression like this in front of you. I'll talk about this betas so that you have more clarity. Now the remaining part of panel data is on betas. We'll talk about it right now. So this is an expression which can work for panel data. You're free to react if you have anything to ask.
Sir, I have a question here.
Please go ahead.
So basically, in that equation, what we are doing is keeping time as a constant, and we are changing the company data for given
Here
variable.
you are talking about, or I'm talking
Yes,
about?
yes, here, sir, here. This
No,
equation.
here we are not fixing anything. We are having both together. When I'm saying IT means, you can put it this way. Let's say one company for 5 years, second company for 5 years, third company for 5 years. So practically, I'll be having data for 3 companies for 5 years. So 15 observations are going to be with me. Okay.
Yeah.
So that is there. I'm not saying that don't fix a company, rather all 3 companies. So one company, 5 data. Second company, 5 data. 5 data means 5 time period. Third company again for 5 years. So that way I'll have 15 observations. Have I answered?
Sir, so then when we write the equation, there beta 2 x2 means yeah, this one. So when I'm writing x1 IT, I'm writing this for a variable one. Let's say for
Yeah, correct.
ROI.
Yeah,
Let's
this
say
is
for
for I.
ROI,
Yeah,
and that is for
yeah,
the
correct.
companies.
For ROI, 15 IOC, I mean, interest coverage, ICR, interest coverage ratio.
And sir, for all of those, the coefficient remains same. That is beta 1.
That is something which is yet to be discussed. So that
Yes.
issue, you leave it to me right now. Let me open that discussion. So
Okay.
I'm saying that I have to discuss about betas.
Yes, sir.
So
Thank you.
right now I have just given expression for this. So this much is clear. Just wait for 5 more minutes for betas. We'll have discussion.
So what's the
Yes.
last term?
Last term is error term. But this is modified error term. We'll talk about it again. This is error term. Again, it is error term. But this error term is having both suffixes. So we can say that it is meant for panel data. Right?
Yes, sir.
Any other question? So here, now things are going to be in panel data. First thing first, that it reveals more information. It tells you more stories, tells you more. When I say more means as compared to either time series or I mean cross-sectional or time series data. So it reveals you more, it tells you more stories. And when we say the loss of degree of freedom is also quite less, because what we are saying that we are not missing out time, we are not missing out on cross section, we are having both together. So we can say in a way best of both the worlds are there when we talk about panel data in this setup. But when we are trying to address both, that too at the same time, so when I'm saying that this expression of panel data is going to reveal more, but estimating that will also become equally difficult. On one hand, it is going to tell you more stories, but on the other hand, estimation is relatively difficult as compared to either time series or cross-sectional regression. So panel data regression is difficult to estimate, but if you can successfully estimate it, it reveals more information, and the loss of degree of freedom or loss of additional information is also less as compared to cross-sectional or time series. So these are the state of a benefit of using panel data. But when we say what are the drawbacks, then downside of the story is that it is difficult to estimate. Difficult to estimate. So estimation problems are very huge when it comes to panel data. But one thing has to be very clear, as I have explained to you. Here we talked about cross-sectional, here we talked about time series, right now we are talking about panel data. One thing is common, that it is regression. Regression, when I say, then we have something known as Y and something, we are saying X, means there are X or X's and we have got Y. So dependent variable and independent variables are very well part of all three types of regression analysis. So panel data is nothing which is coming from some other world. It is not like that. Panel data is also plain and simple. If I explain you in plain and simple terms, that is also a regression. So it takes also time to understand that panel data is also any other type of regression. It is nothing else. It is a regression. So as I have explained to you with the help of this expression, I'm starting with this expression. So intentionally I have shown you. So there is no difference. It is just a regression, but with complication. As I'm telling you that it is good to have more information when you have panel data. It is good to have a less number of loss of degrees of freedom. Freedoms are lost less. You have more number of options or more number of inputs are there, but it is difficult to estimate. So when it comes to estimating panel data, I'll continue with that expression which I have just written for you. First thing, what we are going to take up is discussion on beta, and we are talking about slopes. We'll talk about coefficient. Two things are all the way every time. Whenever we talk about any type of regression, if I just write this way, alpha plus beta, or even if I write beta 0 for the sake of consistency, beta 0 plus beta 1 x1 plus u. We used to normally write this way. So what we are saying that these two are the coefficients all the time. Any type of regression, you will find intercept and slope. Slope coefficient, we can say, or you call it beta coefficient, and this is usually known as intercept. Intercept. So intercept and slope coefficient, both are there all the time, and same thing is going to happen in panel data regression as well. Beta 0 is intercept, beta 1 and beta 2 can be termed as slope coefficients, and error term we used to write u, right now I have written v, but with two additional thing, it. So now we are talking about, as I said, we'll talk about slope coefficient first. Slope coefficient. So when I'm saying to slope coefficient, so what is happening that if I write in a slightly different way, if I say, let's say we'll talk about B1. B1 is corresponding to X1, nothing else. So B1, I'm saying that B1 could have been written this way also. B1 IT. Are you with me, all of you? I could have written that way. As somebody was talking I mean, it can also vary with the I, it can have different values with the T. So beta 1 can also vary. You are with me?
Yes, sir.
Yes, sir.
So, I mean, let's say I'm talking about I first. We have got three companies. So what I'm saying that beta 1, let's say for first company, T, let's put it, I mean, ignore the T option. And then we could have beta 1 for X1. Beta 1 first is for X1. And second for second company, beta 1 for third company. And I have to talk about time also. Then I'll say that, let's say this is for first year, this is for first year. And likewise, I could have 5, and there's no end to it. Second, because I have exhausted with all three companies. So again, we have got 1, 2, 3, and then beta T. It's becoming complicated if you can follow what I'm saying. Look at here. Here we have talked about for X1. Here we are talking about X2, second coefficient. So for X1, what we are saying that for X1, beta 1 for first company, for second company, for third company. And what I'm saying that here it is for first two 5 years. Here I can say if I put it 1, I'll say this is also there for 5 years. So beta 1, 1, 2, beta 1, 1, 3, beta 1, 1, 4, beta 1, 1, 5. Similarly, I can talk about beta 2 is 2. This first is for this. So 1 is for this. Similarly, I can say 2 is for this. So again, I can have 1, 3, and there for 1, I'll have 1 to 5, 1 to 5, 1 to 5. So let me complete at least beta 2. This is for second company, this is for third company, first year. And likewise, I could have 5. So what we are finding that it is becoming complicated if I have to talk about it. So one first strong assumption. What we are assuming poolability. Though this term will be used in a different context after, let's say, half an hour, but I'm using poolability. We are going to pool it. So what we are saying that assumption, the assumption is we will have one test known as Chow test. Chow test used in a typical situation, but I am just giving the general idea about Chow test. What I'm saying, it is assumed that beta, let's say for 1, I could have written it for 2 also. I can ignore beta 1, 2. 1 means for x1, 2 means for x2. And IT I am writing. And I could have written as like B1, that's it. And as alternate, I could have written it beta 1 IT, beta 1 IT is not equal to beta 1. So this is the pair of hypothesis. We are going to have Chow test. And Chow test is going to prove if Chow test is rejected. Look here, if Chow test is rejected, it means what we are saying that this poolability is not possible. Please pay attention to what I'm saying. I'm saying if Chow test is rejected, it means clear cut interpretation is that pooling is not possible. Pooling is not possible. By the time we say that it cannot be pooled, I mean, you can't put the data together, then in normal course, panel data will not be talked about. Rather, we have to talk about specific cases. A specific case. And that specific case we are not studying, and I'll give you a name at least. There is known as hierarchical regression model. And second could be a random coefficient panel data modeling. Random coefficient panel data modeling and hierarchical random model. So if Chow test is somehow rejected, then we have to have them. And when cannot be rejected. So if I say that if cannot be rejected, then we'll study this. So in the case of rejection, straight away, poolability is not possible, and this is the option. And if it is not rejected, then only we'll talk about panel data. So what we are interpreting out of this discussion is that there is an assumption about the slope coefficient. If you pay attention, slope coefficient, I said that I could have written B1, beta 1 as beta 1 IT. Then I'm testing this test of poolability of the Chow test. And I'm trying to tell you if this Chow test is not rejected, there is no sufficient evidence, then we'll assume that beta IT can be written as beta 1. Similarly, beta 2 IT can also be written, because this is one I'm writing for the sake of understanding only. Otherwise, this is a general test. It is for all these slope coefficients. Whether all these slope coefficients can be written like this or not. I could have written, if I write it more typically in the language, I could have written that beta k IT is equal to beta k. K stands for regressors. Like in my example, the example which I have taken, K is 2. I have taken 2 regressors. And this more general form of Chow test. Beta k IT is not equal to beta k. This is the more journalistic approach to talk about Chow test. So this is the thing. So if this test is rejected, then straight away we go to these type of complicated model. But it's not that people don't do it. Anu Gamani, she has done her PhD on this topic from IIT Roorkee. So her topic, her tool which she used to do the analysis was hierarchical regression model only. So it's not that people don't do it, people do it. But right now, when we talk about normal usual panel data, then we assume that slope coefficients are not having problem of individual effect, whether it is cross-sectional or time series. and we assume that there is no problem in poolability, means we can pool, or beta KIT can be taken as beta K, or the way I have written, this is something which is an admissible form, provided Chow test of poolability cannot be rejected. If it is rejected, then we are done. Then we have to transform this, and obviously the way I have written, probably we have to write that way. But we are confining ourselves because the around 90-95% of panel data discussions are assuming that poolability is there or Chow test cannot be rejected. Are you with me? Then I can proceed. I've talked a little heavy thing, poolability issue. Yes.
Two questions. So pooling is
Yes,
to
yes.
put data together,
Uh-huh.
and correct.
One of you mute, please. Tana, can you mute? Let him ask. Tana was asking, whoever was speaking, please continue. Other fellow can. Yes, Tana, please carry on.
So my question was, pooling is to put together the data.
Come again.
Pooling is to put together the data.
Pooling is basically the context in which I'm talking is, pooling means you are putting the data and without bothering. If you, I'm just going to use some, some terminology, please pay attention. It's not the casual statement. I'm saying by the time I have got I or T, by the time I'm talking about I or T. So I is talking about individual effect. I is talking about individual effect. Please pay attention, individual effect, but from the cross-sectional side. And this is also lambda, I've not used, I'm using it. I'll show you T, sorry, let me use T right now. T. So when I'm saying T, still I'm talking about individual effect. Individual, but right now when I'm saying individual effect, I'm talking in the context of time. You're with me? So I and T, they talk about individual effects. And I talks about cross-sectional individual effect, and T talks about the time individual effect. So when I'm saying poolability in the context in which I have used, I'm saying that for time being, when we talk about slope, ignore I, ignore T effect for slope. Am I clear? So for slope coefficient, ignore the individual effect, whether it is cross-sectional or time. But this is only for slope. This is the assumption of Chow or assumption of poolability. If this assumption is holding true, we can go ahead the way we have planned for whole panel data discussion, and I am repeating 95% panel data discussion is done on that assumption. But if Chow test of poolability is rejected, means slope is also having differentiation with respect to cross section or with respect to time, then we have to go for advanced features of panel data, which, as I said, hierarchical regression model or this random coefficient panel data model can be used. I hope panel Mantara, I have explained to you.
Yes, sir.
Anyone else? Anyone else?
One last question.
Please go
Could you
ahead.
please elaborate on the full form of HRM and RCPDM?
HRM is hierarchical regression model. Hierarchical regression model. And RCPDM is RC random, C for coefficient. This PDM is panel data model.
Sir, when the condition for Chow test is rejected, we do not proceed with the regression model as of now, right?
No. What I'm saying, the discussion, what is in store, that will not be sufficient. Rather, we have to touch these areas, which will not be touching. But I gave you example. People do it. We have people here in IBM Pune, those who have applied these two models. So those are advanced things. I don't think so that we have enough time to address that. But individually, if you guys are interested, you can get back to me. I'll help you, provided you are interested. So for a larger class setup, that's not justified to go into that type of integrations.
Yes. Okay.
Within Pal data, as I said, 95% of world of Pal data is already covering this assumption, assuming that tunability is there. So world, 95% of the world is in itself pretty big. There are countless, many books are there and many stuff is there, and I don't think so that I'm trying to understand for the last 5, 7, 6 years, Palette specifically, and I have got hardly 3-4% I would have understood. So you can understand that despite the efforts of so many years, I could have managed only 2-3% to think the world which is still unexplored within this poolability discussion. But if there are some requirement too specific, then we can obviously go and go for that, or if there are cases where poolability is rejected, we can very well go for random coefficient data. It's nothing, nobody is stopping, right?
Yeah. Yes. So I was asking regarding the as a curriculum, as far as curriculum is concerned. So like
No, I
right
don't
now,
think it will be. In course, we won't be covering. You want to cover? Vijay, not Digay. Is
sir,
your name
considering
Chandrasekhar?
sir, considering it's only 5% people go there, I'll
So
prefer to
you,
stay
which
with
your
95%.
name is Chandrasekhar Digay or your name is Chandrasekhar? No.
Yes, Vaijanath, sir. Vaijanatھ. Vaijanatھ is my name.
Vaishnav.
Chandrasekhar is my
Vaishnav, so you
father's
meet
name.
me offline after the class at what time? Quarter past, yeah, quarter to 5. You meet me, call me, I'll talk, I'll
Yes, sir.
discuss.
Sure, sir.
So
Sure, sir.
let's bring some problem which you want to address, so that we can work, because talking in air will not help. So think some problem which you would like to address with the help of, but first of all, when we get data, first of all, you have to get the data. Then we have to test the data. If poolability is not there, then only we can think. So as I'm saying, 95% cases, you will find that poolability is there. So we can't create a problem to, we can't look for a data to suit the problem. Problem should be there, and then we should look for solution. So Vajan, are you following? So if you have
Yes,
a
sir.
problem, I'll definitely help. But problem should qualify for that. No? I can't
Yes, sir.
create artificial problem for that.
Yes,
You understood?
yes,
So
sir.
you
Yes,
are
sir.
most
So
welcome. Meet me
whenever I have, whenever I
Sure.
have that kind of problem, I'll just.
You should try to find out and get back to me. I'll share.
Yes. Okay. Sir. Thank you.
Yes, yes. Any other question? Yes. So we are talking something slightly tedious. We can understand. But if you keep on asking questions, then probably I'll be able to demist. I'll be able to explain. And so far we are again landing up on this. We are taking this expression as meaningful, but again I have to tweak. So far I could have been successfully be able to defend using of beta 1 the way I would have used in this expression. But still, even if the Chow test cannot be rejected, poolability has been accepted. Still, now the real discussion starts about the panel data. I'm again going to tweak this expression, but separating the whole discussion, which I'm going to do from the this part of the discussion. Right now, when we talk about, I'll be writing panel data as PD. So what we are going to do, the whole discussion is going to be based upon beta 0 and VIT. So error term, I have a corresponding question I'll again ask. Intercept. So the whole intercept. The whole discussion is going to be on beta 0. Remaining discussion of PD is going to be either on beta 0 or on VIT or combination of that. I have a corresponding question. If I say that whole diagnostic testing in plain simple regression, diagnostic testing like we talked about heteroscedasticity, multipolarity, autocorrelation. So what was the key there? What were we trying to address when we were talking about heteroscedasticity? If I say, context, if I'm having, let's talk about, we are having Y, we are having X, we are having beta 0, we are having beta I. Beta I is nothing but the slope coefficients, and we are talking about intercept. And then we have got error term. So what we were talking about when we were talking about heteroscedasticity out of these five, if I say 1, 2, 3, 4, 5. So 5 set of items are there when we talk about regression. Endogenous variables, exogenous variables, we have got intercept, we have got slope coefficient, and then we have got error. My question is, what we talk about when we talk about diagnostic testing, any type of regression for that matter? Yes. Vajnath, is he there?
Yes, I am here.
Please throw some light. Where is this Raj Vardhan? Is too.
I'm here.
Yes, Raj Vardhan. What's your opinion?
So can you repeat? I couldn't even understand what you.
I'm saying we have got these 5 things in any type of regression. Heteroscedasticity deals with what? Out of these 5 items, where we draw maximum attention when we talk about heteroscedasticity in the data. Out of these 5, what we try to address?
Sir, I won't be able to answer this.
Okay, anyone else? Can you even define what was heteroscedasticity?
Sir, variance of error term with respect to independent variable.
Saniket is absolutely correct. We are talking about error term. So variance of error term is something that was the point of discussion. Similarly, when we were talking about autocorrelation, we were talking about ut is equal to in time series ut minus 1. Some beta is there plus something other. Beta is significant, we'll say that there is autocorrelation. So practically multicollinearity is also not exactly related to error term, but to some extent we can say. Test term specification, when say specification, test is the reset test as we studied, then that was also talking about error term U. So it means a lot of discussion in financial or when we try to understand data in little depth is about the error. If you recall error, then you have the original data, then you have got estimated data. Whatever is not defined, error, undefined, unexplained portion, that is known as error. So discussion is always on what has not been explained, not on what has been explained. So same thing if I try to draw analogy between normal regression, whatever we have discussed and what we are going to discuss, then we are only adding, this is there, this was there. At this term, this error term discussion is nothing new. What is new in this panel data is the intercept. Intercept is new, that too in a setup where we are believing that data is poolable or Chow test cannot be rejected. I hope you are following me.
Yes, sir.
If I ask you what you have understood so far, I'm intentionally giving you more time because unfolding panel data without ensuring that you are clear will not serve any purpose. So let's talk what you have understood so far when we have talked about. Can you explain poolability, what I discussed? At least, other than these 3-4 students who have continuously talked with me, other people, what is poolability thing, what we have discussed? If you don't speak, then I have to take names, I have to call names. Where is Akash? Akash is missing. Abbas.
Yes, sir, I'm here, sir.
Yes, Abbas. Tell me, what is poolability? What we have discussed?
The poolability is basically can we use the data simultaneously? All the data will something like
No,
that.
that is not the context in which we have talked about poolability. We have right now talked about Chow test. What does it mean when we say Chow test is not rejected? Where is Priya Kushwaha? Is she there?
Sir?
Yes, Abbas. Carry on.
No, sir, it was Shivardhan.
Shivardhan, tell me.
So basically, we are looking for a time series and cross-sectional data. We look for either eye effect or time effect. And
Okay.
for chow test, we'll see if for slope we can ignore eye effect and t effect, then we are applying chow
Even has
test.
given the final words. This is there. Perfectly all right. Very great. What about other people? I want others also to, have a little more understanding. Vaibhav is there? Vaibhav Shrivastava. Then where is Tanushri? Tanushri performs good, but never comes part of a discussion in the class. Tanushri, is she there?
Yes, sir.
Yes, Tanushri. What we have talked about, chow test. What Shrivarshan said, that makes sense, or he just said for the sake of saying something?
No, sir. Whatever Shivardhan said, it makes sense.
Acha, what do you explain? Can you, explain in your own words?
So, from what I understood is that in order to, we have to ensure that the slope of the coefficients can be pulled together, something of that sort. I'm not very sure about it.
Mhm. Sneha, Karn, Sneha is there? Rajiv is there? Rajiv, Satish, Punajit Yadav. I'm noting all these names who are not responding. Inform them. Pankaj Kumar Agarwal. Sarthak Amit Kumar, Sarthak Mehta, whatever is the right name. Amit Kumar, Sarthak. Manisha just came and went away. Where is Manisha?
Yes, sir.
Yes, yes, Manisha. What she wasn't explained. Can you throw more, input on that?
I can't, sir.
So you could have asked. Is she still having mic problem or solved?
Solved, sir.
Yes, Ayushi. So what's your understanding on this?
So I'm still confused in it.
So you can ask what is the confusion so that I will help. Yes. Yes, Ayushi, we are listening.
So I didn't understand the pooling effect. And that at that point of time, my mic wasn't working, so I couldn't speak.
You could not understand.
Yes, sir.
No, we just tried to explain that this is the expression when we are saying that IT means the value can change over the for three companies for 5 years. So, but beta we are not changing. So that was a discussion. We are having some assumption that the beta can be assumed as constant across the cross-sectional and across the time period. That is assumption. And if this assumption is true, we'll say that yes, we can manage with this expression. If this assumption is not true, then we have to look for something other than that. I mean, we can't manage with this. Is it enough?
Yes, sir.
Where is Ayush Roy? Still not reachable?
Yes, sir.
Yes, Ayush. So, yeah, you are still not audible, very clearly not audible. Yeah. Please speak a little louder.
Yes, sir. So I is the individual effect from cross-sectional side, and the T is the individual effect from time. And
Okay.
we do not consider I and T, ignore I and T, for as this is the
For
assumption
slope,
for the
for,
chow
for
test.
slope, for slope only.
Yes, for slope. And
All right. Yeah, yeah, carry on.
the
Carry on.
null hypothesis for this is B1 IT is equal to B1, and
That is
H1.
for chow test. We assume that chow test is accepted. I mean, cannot be rejected. We can carry on with this expression, what we have written.
Yes.
Good, 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 good. Great. So now we are going to talk about, as I said, that we'll be focusing for the remaining discussion on PD, either on intercept or on error term. So I'm just going to give you more terms. So what I'm saying that we will be I'm giving you two new terms rather. It's mu I, and saying lambda t. And if you might have paid attention, I said that we are talking about individual effects. So I was for individual effect with respect to cross section, and T was their individual effect for time. So this is something which is important, individual effect. So we are going to use some expression. So this expression is meant for individual effect for cross sectional, and this is meant for individual effect for time series or for time. I mean, if I ignore the S part, just time. So this is these are two terms which we are going to start. And what we are saying now, if I repeat, yit is equal to beta 0. Let me change this. The way I have changed the error term, let me call it alpha. I'm not putting anything because I have to explain alpha plus beta 1 x1 it plus beta 2 x2 it plus vit. Now this is the expression. Now we are going to explain alpha and vit. If you remember, we talked about either intercept or error term. So there are now possibilities. What are the possibilities? That individual effect can be fixed. Now I'm using this fixed term. I ignored using this term today intentionally. And this individual effect, when I say individual effect, it means I'm talking about mu. Mu is different from u. We used u with the in place of error term. So we'll be again using that. I'm not saying we'll not be using it, but I'm using this is mu. This is not mu. This is not u. This is mu. So mu I or lambda t. So individual effect, either cross-sectional individual effect or time series time individual effect. This is fixed or this is random. Slightly clear. Random, when I say, then random is there. It means the individual effect are part of error term. And when I say that this is fixed, then I'm saying that individual effects are part of intercept. So practically, what is going to decide whether it is fixed or random, that is the nature of either mu I or lambda t or both of them together. That is also and lambda t. So one is individually, this individually or both of them together. So three possibilities. So these three will decide whether the individual effect or mu I and lambda t will decide whether the individual effect, or as per the data when we take, then within the data the individual effect of cross-sectional individual effect of time will take a call whether in a particular data setup whether these individual effects are fixed. If we can prove that it is fixed, then we will be estimating and we will be believing that first of all we have to find out, we have to decide this whether the individual effects are fixed. And if we come out with the result that it is fixed, it implies that the individual effects are part of intercepts. And if we find that individual effects are having the random tendencies, then we'll say that if I have to write the expression, I'll write the expression that individual effects are part of error term. I'll clarify this more by taking fixed effect first. And as I have just said, that fixed effect means we are talking about the individual effects are fixed. So, and they are part of intercept. So they are not randomized, means they can be clear cut found and can be written in the expression. But when we are not sure whether they are going to be fixed, the fixed tendencies of the individual effects are not strong enough. Rather, first of all, they are there. Only then we are talking about panel data. If they are not there, then that's an entirely different thing altogether. So we'll talk about that also. But we are assuming that individual effects are there, but individual effects are having a tendency of not being fixed. Then it means they are part of the error term and they are randomized the way error terms are randomized. So if I say that they are fixed, then there are three possibilities. Here I'm saying if I write the expression it is equal to alpha plus beta 1 x1 it plus beta 2 x2 it plus vit. So here I'm writing alpha can be equal to beta 0. As I said earlier, we had beta is as usual normal intercept plus the mu I. So here only cross-sectional individual effect, Second possibility, or three possibilities are going to be there, A, B, and C. The second possibility is that the intercept is going to be lambda t. So we'll say that the time individual effect is there. But we are in all the three cases will assume that individual effects are fixed. Means they can be clear-cut estimated with respect to either cross-section or with respect to either time. So unless until they are fixed, they can't be part of this discussion. So if I take it ahead, alpha is equal to, then I'm talking about third possibility where beta 0 and both the individual effects are present there, plus lambda t. So we'll say that cross-sectional and time individual effects. So this is some two-way approach is there to handle, as we discussed on the second part of panel data. We are having three parts we'll talk right now. And this can be estimated with the help of one-way panel data. But right now we are talking about fixed effect. And if I write I'm writing both, then I'll again allow you to ask. So I'm talking about a random effect, and right now I'll write the expression. Yeah, let me just clarify one thing more so that there's no room for confusion. Yeah. Now we have talked about alpha, but let me talk about VIT also. This whole is part of one. Means so far when we have talked about this, we have talked about only intercept. Let's talk about error. I said that this part of the panel data discussion will be on either alpha or on error. Alpha we have discussed in fixed effect. So in fixed effect, I'm talking about VIT. So VIT, use a simple way. Yeah. So VIT in fixed effect will be nothing but usual error term. Yeah, usual error term. I can write down usual error term. So there's nothing that individual effects are not part of the error term. And we have discussed in fixed effect, the individual effects are fixed. And when they are fixed, they are part of intercept only. They are not part of the error term. And that's why when I'm writing the error term in case of fixed effect, then I'm just saying that there is nothing to be added. And this error term can be written. So this VIT is nothing but UIT, which is the regular error term. So this is the whole discussion on fixed effect. And when I've said fixed effect, I have only talked about either intercept or error term. Now I'll talk about same type of discussion for random effect. When I say random effect, then what is going to happen that individual effects are not fixed. They are random. So when I say they are random, it means they are, when I say it is fixed, then I'm saying they are part of alpha. When I'm saying that they are not fixed, rather they are random, then they are part of VIT error term. Let me write down again the expression YIT plus is equal to alpha, and I'll write what is alpha: beta 1 x1 IT plus beta 2 x2 IT plus VIT. And right now, alpha is nothing but beta 0, nothing else. This discussion gets over here. And we'll say that VIT again, it will have three options. VIT is equal to UIT, usual error term, plus mu I. Second option, VIT is equal to UIT, the usual error term, plus lambda t. And third is putting both of them together. UIT plus lambda, plus mu I plus lambda t. So if I, these are the comparative way to explain things, intercept and error. So now the forum is open. I think that I would not go beyond this. I want you to talk about it. I'm 100% sure that 95% of you would not have understood what I have just talked. So probably that's why I'm asking you, poking you intentionally. Please ask. Otherwise, I have no other choice but to say yes. It's okay. I'll move on. The forum is open. Don't make me again call your names and request you to ask. Please go ahead. Yes. So Vaishnath will say something today. It's better that Shrivadan and Tanay can be given some relaxation. So Vaishnath,
Yes, sir.
yes, tell me. You have any question? Yes, go ahead. Yes.
I have understood that first
Please go ahead.
discussed about the beta term.
Hmm.
So the first thing we have understood about is in the beta term where the individual effects of first we discussed the effects of company and the cross section and the time effect, and then
Yes.
we discussed the same effects for error term.
Correct.
Which we generally calculate about which we generally calculate or which we generally consider in while doing regression in case of correlation term. And for that we again formulated some conditions where error term is for the fixed effect. Error term that is VIT is same as usual error, and the individual time effect and individual cross-sectional effect are considered there. But for the next effect, I cannot recall the name exactly.
Random effect.
Random effect, yeah. But for that, the error effects are considered as means it is not individual; it is directly affected, like that. For the last part, that I'm a bit confused.
Okay. I'll give you a summary again. Anyone else? Vaishnath has tried to explain whatever you would have understood. Yes. So Tanushree, anything from your side?
So that Bajana told about the fixed effect, then so for random effect, the alpha becomes equal to beta 0, and then the VIT has three possibilities, and one is that VIT is U equals to UIT plus that error of I don't know what is that, what UI signifies.
Understood. Let me explain, give you the recap type thing. What we are saying, let me give you a separate idea altogether. What we are saying that we have a problem. Let's say our problem which we started with. I'll show you some work so that you find that there's a work, 4 work I found that I'll talk to you. Recently one of my student did some work. I'll show her work in a paper setup. So the data also I have for this. Their study on dividends, and I'll show you the expression, not data at least. When the result which is found out, these are the variables. This is the short form of presenting the expression, and look at here. Yeah. So dependent variable, these are independent variables. Tangibility, a variable has been defined. Business risk, a log of sales, log of market cap. Likewise, there are independent variables. Means not two. It can be as many as you want. ROI, ROE, all you are finding it here. And dependent variable is again defined dividend divided by total asset. So what you are finding here is that this is the problem which in the this paper or in her work she would have tried to explain. So problem was there. So when problem is there, so if I say problem number 1, I'll give you all 4 problems. So problem 1, she was interested in finding out that how dividend which are paid by the Indian companies are related to different variables, including ROI, interest coverage ratio, and other things also, business risk, sales, other variables also. So this is the problem which was trying to address. I'll come to the another problem probably so that you have some variety. And if I just this work you can have. Look at this. What he would have another student of mine. What he has done, he has. I'll show you the output straight away, and then I'll give you what is the problem which he has tried to solve with the help of nonlinear regression. So these are the expressions. Don't waste your time here. Just straight away and come to the output. Descriptives, and here we have got result of static data. Look here, what he has done. He was trying to understand that how in banks. This another problem was on banks, and problem 2, how the non-performing asset in a bank is going to have some impact. I mean, what are the factors which are impacting the NPA level? And what the variable which he has taken is the variables are how efficient the bank. I mean, he would have taken 34 banks, including public and private banks in India. And then a variable he has taken efficiency. I mean, how efficient they are. Efficiency is again estimated by another type of analysis. Then he said that how much NPA is going to be impacted by the owners stake, means promoters, and then institutional investors, and then retail investors, means like you and me. So their ownership proportion in the bank would have been taken. So we call it ownership concentration. So here again, this is the problem. I mean, promoters. So let me come to the problem. Here in the second problem, what he has tried to understand is how NPA is going to be affected by these variables. So here she was interested in doing this study. What are the determinants of dividends in India? So when we have a problem which we try to, and they could have easily done whether with the help of cross-sectional or with the help of time series, but they took a decision that they would like to use the best possible tool so that they can derive maximum information regarding the determinants of dividend or regarding how these ownership concentration and efficiency of bank performance is impacting the NPA levels in Indian bank. So to do that, these are the problems. To solve the problem, let's talk about dividend problem first. So what happened? She got the data. I can show you the data. I guess, yeah, here I have the data. So these are the data she gathered and for a 12 years time period. And I think these are number of companies. This is number of companies she has taken category one company. I think 10, 12, 30, 13 companies she has taken in this category. So one particular sector, 13 companies she has taken, and she has taken it for 12 years. So I'll show you the probably in next class how the panel data is written or data is calculated the way I'm just talking about. So she collected the data and then she tried to estimate again her interest. If I just use simple dividend was as dependent variable, and she was talking about ROI and interest coverage ratio as the independent variables. So when she was trying to address this, then the first job she has to ensure that poolability is there. If let's say suppose we assume that poolability is there. So it means first thing which she could have easily modeled is that she is saying now dividend IT is equal to, as I'm writing, alpha 0 plus beta 1 and ROI IT plus beta T 2 ICR IT plus VIT. This way she can write, and she can assume that beta 1 and beta 2 are constant across cross-sectional and across time period. So once she has done this, then her next obvious job is to find out whether the up now what she has she's left with individual effect and how it is impacting the error term. That is what she is left with. If she is still interested in using the panel data, poolability is done, taken care of. So when we talk about individual effect, then she has to again decide whether the individual effects are fixed or they are random. If they are fixed, then as we have discussed that we can write down alpha is equal to beta 0 plus mu I plus lambda t. Anyone can be missing or both can be there. And if she finds no, the individual effects are randomized, then she will write VIT is equal to UIT. And what if random effect is there? She will write alpha is equal to beta 0, but VIT she will write as UIT plus uh, mu I plus lambda t. That's it. So as per the effect of individual effect, she will take a call that whether she should estimate her model like this or she should estimate the model like that. Interpretation and even estimation of the model or interpretation is all are secondary. What is primary? First to decide this issue, first to take care of this issue, whether data can be pooled or not. And if they say that yes, data can be pooled, then next is they have to study how the individual effect is impacting the data. So it is the problem. And to solve the problem, the data which has been collected. So data will tell whether that data would like to be modeled with the help of fixed effect or that data would like to be modeled with the random effect. Usually a problem has similar tendency. It means a dividend problem usually have a fixed effect. So probably you'll find that the data which you would have collected will also be having the fixed effect. But it is the data which will tell. So problem is there. To solve the problem, you calculate data, and you have to have these set of assumptions if you really want to use panel data. So first of all, you have to take this assumption and you have to prove it, and then you have to talk about how the individual effects are going there in your data. And as you decide that individual effect in your data is fixed, then you will start planning to estimate using fixed effect. And if you find that your individual effect is having the random tendencies, then you will start planning to model your problem. And still, association is between y and x1 and x2. This will not change. But how you are going to model it is, so that is going to be dependent upon this assumption. If this assumption is holding true, then you will talk about this, and accordingly you will take a call. I wind up my discussion, as per the availability of data, it is always good to have panel data analysis because panel data reveals more and it does not have limitation of both whether it is cross-sectional or time series. So panel data is really helpful, but estimation of panel data is problematic. And we started with that first assumption that slope coefficients are constant or not across individual effects. And if we find that, we can take slope coefficient as constant across individual effects. Then next step is we have to talk about the individual effect nature. And if individual effect nature is fixed, we will go for fixed effect model. If individual effects are random, we'll go for random effect model. So right now, if I close the discussion, then I'll say that what are next to be done in this, we have less amount of time. So what we have to do, we have to we have to decide individual effect. Means whether it is fixed effect or random effect. That is something which is the first job which we have to learn. Second is we have to learn how to estimate both fixed effect models and random effect model, and we have to do diagnostic testing. Means there here again you will find multipolarity, heteroscedasticity, autocorrelation. These problems are all the time part and parcel of any data analytics. So diagnostic testing has to be there. The specification error can also be specification issues can also be tested. Third thing is we can this we call it static data, static panel data, static panel data, static panel data. And then third is we'll talk about dynamic panel data. So I'll talk about static and panel in my next class. So far I have already given you a lot to digest. So these are the three things. By the time we have quickly, I think I have created the foundation. So I won't take much time, half an hour or so here, and then 15-20 minutes here and 15-20 minutes here, and probably I'll wind up the whole panel data discussion in my next class. Next class we'll have at the end of the class quiz, and last class is going to be on I guess 16th. So I'll try that just after the class we'll have. I will see to it. I have to submit something before that. I'll see to it. They can be before, or I may wait for 16th. So 16th or before, there will be last quiz. I think all the components have been covered of your evaluation, internal evaluation. Right? So shall we close?
Yes, sir.
Yes, sir.
Okay.
Thank you.